Alright, so this video is going to show you how to start a static stress simulation in Fusion. So that's kind of what we're going for. So the reason we created this beam is because we wanted to do a static stress simulation. It's really easy to do, cable under tension, but if we're doing like our beam here and we're going to do a bending moment, that is really complex to do. So it's kind of easier just to let the computer do the work. So that's what I'm going to show you how to do. So one thing I did forget to tell you last video is that when we are done with our design, make sure you save. So Fusion doesn't save automatically like Onshape does, so make sure you save. Now if you log into another computer with the same account and log into your account, then you will have all your stuff there. So it does save to the cloud. You just have to make sure that you hit save. All right, so we're going to go ahead and do a stress simulation. Now the first thing I like to do is to turn off the actual, can you see it? Alright, so I like to turn off the grid here because it kind of just messes with my perception of everything. So I'm just going to click on this little grid button and turn off the layout grid. That's just going to make life a little bit easier right there, just because it's not messing with me. So if we click on design, actually Fusion has a whole bunch of different workspaces. So we can do renders, which is like a high quality image. We can do animations, manufacturing, drawing, all of this different stuff, kind of like we did an Onshape, except Onshape pretty much only had assemblies and it had drawings. But there's a whole lot of different stuff in Fusion. So what we're going to be doing is a simulation. Okay, so we're going to do a finite element analysis or static stress simulation to kind of test and see what this looks like when we put a load on. So we'll go to simulation. And I've already run a few, so I have some stuff here, but you probably won't. So we just have to go to New Simulation Study. And what we want to do is a static stress simulation. This is going to act like putting a load on our beam, and we're going to get to see what it does. So we'll go and create study. Okay, so what we got here is our beam. Just close this so it's not confusing. And it's kind of a left-right kind of thing. So if we look at, we don't really need simplify, that just says simplify, but don't want to do that. The first thing we have is materials. So if we go to study materials, we can see because we already selected our steel, we have steel in here, so we don't need to redo that. So that's one of the nice things about Fusion. If you select a material in your design, it sticks, whereas if you do that in Onshape, you have to reapply it when you go by and do a new simulation. So just make sure that you have steel, or your structural steel. If not, you have to go back and reapply that. So we'll hit OK because that's there. So constraints is our next thing that we're going to do. And we're going to have some structural constraints. And the ones that we're going to have are fixed. So the first simulation we're going to do is going to be fixed on both ends, just like if this I-beam were sitting, in a skyscraper or something. There's my hands. Okay, and welded or riveted on each end, so that's going to be fixed. So you'll have to do some other ones, but I'm just showing you how to apply these. So if we just make sure it sets to fixed, then we can see that we can select faces, edges, or vertices. I want to make sure I select the face, right? Because I want that whole face to be fixed. Right, that's just like it's welded or riveted to a different structural element. Then we'll zoom in here and do the same thing on this one. Make sure this one is fixed, and you can see the little lock like pops up there. So we'll hit OK, and we can see that I have a lock on that end and a lock on that end. That means this is fixed, right? So it's just like it's an I-beam in a construction zone where it's been welded or riveted and attached. So we'll hit loads, and the first thing we want to do is toggle gravity on, because we do want to take gravity into account. So we'll toggle gravity on, and we see that that direction is not really what we want. So it might be for you, but it wasn't for me. So if gravity is not going the right direction, so we need to edit gravity. If only it were that easy. But I'm going to go ahead and select this face here and click on that, and now we can see gravity is going in this direction. So it's on the top flange right there, pointing down. That's cut 101, because we can imagine that beam is sitting there, there we go, in space, and kind of gravity is kind of pulling it down. Okay, that's what we want. So we have that face. There's our gravitational constant. Okay, so now we have gravity pulling our beam down because we want to take that into account as well. The next thing we do is add a structural load because this beam is in a structure. It's part of a building, so we want to add a structural load, and we want to add it to this top plate here. So we can imagine that the weight of the building is sitting there on this structure, and it is pushing down. So we're going to add a force, and now because we did imperial, we're going to keep our units in imperial for this one. So I'm going to do pound force, and let's go ahead and add 10,000 pounds. Okay, so we're going to put 10,000 pounds on this beam and see what happens. So we'll hit OK. Then we also have contacts. We don't really need to mess with that, or thresholds. That's kind of pre-programmed. We'll talk about that in a minute. Manage, we don't really need to mess with, but we're going to go ahead and pre-check. We see that everything we need is required. Right? We can tell that it's fixed on 2 points. We can tell the gravity over here, that's the yellow vector, is pushing down. We have our force, our structural load that is pushing down on this with 10,000 pounds. So I think it's time to solve this. So we're going to hit solve, and that's actually going to crunch all the numbers and run this. So we'll solve the study. Now this will take a few minutes, so it pops up this. We'll see this little loading thing right here. So I'm going to pause this while it's sitting here, loading, and we'll come back when it's done. So we are back. It's gone through and finished. So I've done a couple simulations. This is my third one, so you probably just see this first one. So I'll go ahead and hit results, and it's going to process for a little bit, doing its thing, and then still doing its thing. I'll pause. All right, we're back, and first thing we see is it says very strong, but we see this bending. You're like, oh, that doesn't look good. But by default, Fusion will actually multiply the deformation, so it doesn't actually show you the actual deformation. So the first thing you need to do is come to deformation and click on actual, and we can see that there is no deformation on this. So you're going to do some screenshots for your submission for this. So we'll go to our study, so we click on the results, and then we see some different things here. So the first thing I want you to screenshot is the safety factor. So you're going to do a couple different static stress simulations. This first one, you're going to use the same numbers that I had, and then you'll just have to read the assignment for the rest of them. But your first screenshot is the safety factor here. And the safety factor shows you this ratio of, is this going to break? So it gives it a little bit of a margin of error. So you would not load something, to its max, right? You definitely give it a good margin of error, and that's what this safety factor shows us. So this shows us that this is definitely safe. There's no way under these constraints, under that load, that this is going to break. So go ahead and screenshot your safety factor right here. Next thing that we're going to do is we're going to go to stress, and we're going to go to your von Mises stress. I'll take a second to load. Nice color here. And this shows you the stress. So remember how we talked about doing your stress calculations, and your stress equals force over area? Well, here is all of that right here in this nice little gradient. It shows you all the different stresses on this beam if that force is applied. So you can see that it's not equal throughout the entire beam, right? It's different in different places, and that's actually how stress works, right? In a bending moment, it's very complex. So you're going to go ahead and screenshot your stress, your von Mises stress right here. The third thing that you're going to do is you're going to screenshot your equivalent strain. So strain shows how much it is moving. Okay? So remember, stress is just the force, strain is how much displacement we have, and when we looked at the displacement, we didn't see much, but this will actually show you. So we get our units right here, so we can actually kind of hover over this, and this will tell us, depending on whatever units we had selected, how much displacement or stress we actually have. Remember, stress is dimensionless, but we can see not a whole lot here at all. So, and really what we look at is the safety factor. That tells us that this is fine. But as far as your submission, you have screenshots. So you have a screenshot of your safety factor, you have a screenshot of your von Mises stress, and you have a screenshot of your equivalent strain. So you're going to take those 3 screenshots for this first example analysis, and then I will have a couple of others that you have to do, and you're going to take these same 3 screenshots for each: the safety factor, von Mises stress, and equivalent strain. So there you go. That is static stress analysis.